Hello, this is a video. I want to show some of the changes that are happening in terms of browsers, in terms of the GPU that you can utilize for AI usage. And it's quite important, I think. I think this is a big change because nearly every person has a mobile phone, and there's multiple sensors like microphones, GPS, accelerometers, gyroscopes, proximity sensors, and more. Um, and they're all useful for building applications. You could send all these to the data to the internet, to the API on Google, OpenAI, and all that kind of thing. But sometimes you want a bit more privacy, and sometimes you want to be able to do it more frames per second. If you think about it, if you send it to the cloud, you've got 2 or 3 seconds, and probably more, for the actual data to reach the end site and then come back. So if you're aiming for the 30 frames per second in an image, there's no way you can achieve that because you're going to be able to send one and then 2 seconds later the result comes back, the prediction comes back. So it's just a bit too slow. So you want to lose local hardware. And you also want it to work when you're not connected to the internet. So you could reach for the Apple and Android ecosystems. That's using within their app stores, but I think they're incentivized not to make it easy because they want to take a cut of your funding. They've got a bit of credibility in there as well. They don't want any sort of apps in there, although some of the apps are pretty rubbish. And it just have to jump through a lot of hoops to actually get your apps in there, and you're restricted to a particular platform. So that's where this new technologies are starting to make the impact. So we've got the GPU execution versus CPU. So CPU is generally what you get with 99% of the traffic that hits your web browser. So that means it's just going to be a serial connection or serially executed, and that's good. It's very easy to program that way. It's very easy to utilize that, but it's very slow compared to GPU. So the big explosion that's happened with GPUs is the AI resources, and they can make use of that GPU because they can do it in parallel rather than the serial method. So if you've got 2,000 cores of a GPU, it means you can utilize all 2,000 cores at once and get the results back. Not quite, but it follows that theme. Whereas a CPU, you'd have to wait for all those to be processed serial. So essentially, GPU is much quicker, and it fits the AI workloads. So I'm just going to open some of these up. I'm not going to go through them directly, but this is just to show you and give you links so you can investigate yourself. So this is the WebGPU. It's a new system that works underneath a lot of technologies, which I'm going to show you in a bit. And this is how you can get access to the GPU through a web browser. And it gives you a few examples of who uses it, how they use it. So you can have a read through that. And this is probably the core sort of technology that's allowing this at the moment. We've got TensorFlow, so this works on top of. I hate it when it does that. Let's go and right click and open new. TensorFlow.js. So this is TensorFlow from Google, but it's a JavaScript version. So the JavaScript version just means that it can run within the browser. So I'm using here something called Solvit, which is a new platform. It's a Jupyter-like notebook platform, and this uses Python. But with Python, you only can use it server-side. And so if you want to execute any code on the local host, you've got to use JavaScript. And that's where just JavaScript, TensorFlow.js JavaScript comes in. So it can run and execute code locally. So it means that you're not having to run all these models on your server infrastructure. You're passing the actual execution to the local system. And what we've got here is got different models that you can run. So this is I've linked you to the models section, and these are all that are pre-built. So you've got pose detection, face landmark detection, body segmentation, hand pose. There's a bunch of different sort of models out there. You don't have to stick to these models. There are other models, and we're going to do a few more videos just to show you other models that you can build as well and use. But you can create your own JavaScript, and I'll go through very briefly how this is done within this application that I'm going to demonstrate. So that's TensorFlow, and then they've got another one which is called Media. What's the full name of it? It's called MediaPipe, and it's from Google. And they've made it really easy to run AI models on web browsers. So you can see here, I've got some examples. Again, I won't go too much into detail here. I'll just explain it through a particular project which I'm going to. But I just wanted to link and show you the core technologies that are making up this. So it's not, because it's Google, it doesn't mean it just runs on Google. It also runs on Apple as well. So if you click some of these Vision, you can see where you can actually use this. So anything that's got a web browser, essentially. So that could be Google, it could be iPhone, it could be your PC, Linux, wherever. And that's what sort of makes this interesting. And okay, so that's that one. So what I'm going to do in this notebook is just show you the project called HueVision. HueVision's an awesome little package that someone's developed. So that's the link to this one. I've got a link to the original GitHub. And it's done by this code, the guy. This guy here. Is a data scientist, and he's just created a little example web package, and I thought it would be a very good way to showcase how to use these technologies within a web browser. So I think what I should do at this point is just give you a demo of it. So what I'm going to have to do is just deactivate my camera so I can show you. So if I open up this application here, I've got to right click, open this new tab. What it's going to do is it's going to follow through and look at where I'm pointing to on the screen. So if I click on Start Detection, it's got a picture of me, it's got the media FaceMesh started here. You can see one eye, another eye, and it's going to record my iris position, and also where it's going to send this little eye box to the TensorFlow model. So what we're going to do first is we're going to calibrate. So I'm going to look at the top left little circle. I'm going to look at the little circle on the right hand side now. It's the orange dot. Okay, on right hand side, bottom left, and then bottom right. So it's only done 9 points. You can do more, and the more you do this, the more accurate it'll be, and that's the idea behind it. So what we've got to do next is start the training. Start training. It's in progress. You can see down at the bottom, epochs goes to validation and loss. Too quick to actually stop it there. So what we need to do now is just start a session, and then what we're going to do is going to look at different points on screen, and the model will hopefully track where we're looking. So look to left, up right, down, top right, bottom, and then middle. So it's tracking where I'm looking, which I think is pretty good. Just for a very short demo. Okay, so if we stop tracking and draw a heat map, you can see everywhere where it's displayed. That's the app in a nutshell. So let's flick back to here. What I'm going to do, because I need to switch off the camera, I'm just going to show you the code. for the index page. So this original code was all in HTML, and then just referenced a JavaScript to do the heavy work, so the actual code that's running inside the browser. So it's very JavaScript heavy, the code. So if I go back to here, what I've done is I've converted it to a FastHTML page, which can run within this Solve environment. And then I've displayed the information and sort of routed it out. So it uses something called Starlet, which is Fast API, same technology Fast API uses. So I've imported all this information, imported the JS files, and then I've just written this route, which is the default index route. So that is this site without any page after there. So usually if you've got another page, you'd have another slash on there. I've not got that. So it's just a root index page. You can see here we've got a training panel. Go back here. This is the heat map panel. So in fact, let's just find the heat map panel here with this tag here. Go back, go to new session. And we've got a session. Session panel. Here we go. And then we also got a training panel as well. If I can get it. Retrain model, and then training panel there. Training panel. Training panel there. That's all the HTML code. So HTML code essentially just tells you how to display the web page, and the JavaScript is all the action and information behind that web page. Yep. So that's all I've explained here. And you'll have an extra sort of thing in the middle here for the actual the main pane, and then you've got the video element here, which is again just to sort of tell you this is where it's going to be located. Okay, so I'm going to close this for now because I've finished with this and free up the camera. And I'm going to switch on the camera back on so you can see me down the bottom. There we go. Right, so what we've got here I think we missed a bit at the top, didn't we? Because I just skipped sections. So you understand what the actual application's doing. Okay, so we've explained that we've got all these sensors and we've got all these mobile phones out there. We want offline, we want privacy. Okay, so how do we actually do it? So I explained a bit about Python and FastHTML, or just the HTML tags as it is in the original GitHub. And then the JavaScript does all the heavy lifting. And this gives you a brief overview of what each of the JavaScript does. I'm not going to go through these in depth. I'll share the actual dialogue so you can actually go through it yourself and diagnose it. The main one that I'm going to concentrate on is the training to show you how the model's been built. So we've gone through the imports. Let's close that one. One of the reasons why I wanted to get into this notebook format or this dialogue format is just because I think it's the best way to explain code and go through and solve problems and understand code. So what we've got here is all the modules again for JavaScript, but also the flow. So the first thing that happens when you start up the FaceMesh is you have to grant permission. So you have to do that for every sensor on web browsers, I believe. And then you have to user clicks at the user moves the mouse by looking at the cursor. So you don't actually look at the cursor, you're just looking at the different samples, the orange dots on the screen. When you're looking at those different orange bits, it's saving an image, so just your eyes locations, and then we train the model, and then we predict where the user is looking, and that's where we've got all those dots across screen. So we're putting in the eye locations, the iris locations, and then we're using that to predict a pixel location on the screen. Okay, so let's have a look at these. So what I've done is, this is a nifty feature of Solve.it. What you can do is you can list all the files in Solve.it, and then you can go through and you can add a note message and you can add a raw message. So what I'm doing is open up each of these JavaScript files. This is because the Solve.it platform, as far as I know, doesn't allow you to view JavaScript within the actual notebook or dialog. So what I've done is I've created a note, and then I've just inserted the item. The item is just the file name here. You can see the file name there. And then underneath that, what I've done is I've added a raw message. So you can see there, raw. Expand that. So this is the note that I've added, and then we've also got the raw message in there. So let's go back. Let's look at training. So we can see here we've built the model using this create model function. So it takes the eye inputs, that's that letterbox that we got from MediaPipe. So it's only 25 by 55 pixels, so 55 pixels wide and 25 pixels up. And the metadata is the 4 iris positions. So the iris positions are 2 for each one. So whereabouts in the eye coordinates is the iris. And that's for 2 sets of those. And then it uses a convolutional neural network. Max pulls it, flattens it, drops out. So drop out just means it takes some of the neurons away, just to make sure you're not overtraining on particular elements. Concatenates with the metadata. So the metadata is the 4 iris locations, and then it creates a dense output. So that's the X and Y, so that's the pixel coordinates that are the prediction. And then we run fit model, which actually trains the model. And it's using the Adam optimizer and MSE for loss. And then we can save to local storage if we need to at the end. So you can save that model and use it. So if you get a good calibration, you can save it against your particular facial features. Yeah, and that's it. Yeah, so I thought it was worth sharing that. I don't want to go too in depth. I don't want to make it a massive video, but I just want to explain a bit about this technology in general, and then just explain and give you some room to sort of investigate yourselves about how it's all made up. Thank you.